as I mentioned to you before, so what happened is that for the case of variation of parameter, for the case of non-homogeneous equation, so which is this equation right here, so there are two ways of solving them. Okay, so one method is called as the undetermined coefficient, so the method that we have seen previously, for which the solution is given by yc plus yp. And the second method is called as variation of parameter, which is the method that we are about to discuss, and solution is given by uy1 plus vy2. So in the calculation, you have to find what is u, y1, v, and also y2, and all you have to do is put them together. As I mentioned to you before, like what is the difference between the method of UC and VOP? So the method UC is actually very limited. You can also only use the UC method when your function on the right hand side, f of x, is exponential, polynomial, sine and cosine, linear combination or product of those cases. But if you come across something that is not listed as that, automatically you cannot use undetermined coefficient. Okay, but VOP on the other hand is a very powerful method. It can solve any function of f of x, so that will be the difference. But of course, when a method is powerful, like the calculation is going to be a little bit more complicated compared to the simple one. Okay, so actually VOP is not that complicated, but there will be integration involved, that for sure. So that is what complicates the calculation. So whenever the function is more complicated, automatically the integration is going to be more complicated as well. Okay, so there are like 5 steps that you have to follow in order to solve for variation of parameter. So if you have a look at the method in the book and the method that I'm about to show you, they are different. So I would strongly recommend for you to use the method that I'm about to show you instead, because this is going to be much easier compared to the one that you have in the book. Okay, so step number 1 is what you're going to do is you're going to find the YC. Okay, but I want you to remember, I want you to notice the fact that for the case of for the case of VOP and UC, the first step is always the same. So you are going to find the YC. But for the case of variation of parameter, so YC has a very important role. Why do I say that it's a very important role? Because if your calculation, if you calculate YC wrongly, if your solution is wrong, automatically the whole calculation is going to be wrong. Okay, because your calculation start with the y1 and y2, and you're going to use that all the way until step number 4. Okay, so all the steps is going to require you to use y1 and y2, and that actually comes from the yc. So please make sure that your yc is correct. Be very careful when you do your calculation. Okay, so what happens is that from the yc, you're going to identify y1 and y2. So how are you going to identify y1 and y2? So let me put an example on the side right here. For example, let's say you do your calculation and you come across a case of distinct roots. So you get a exponential of x plus b exponential of 2x. So how do we determine what is going to be the y1 and also y2? So all we have to do is remove the constant a and b. So when I remove a, I get exponential of x. When I remove b, that is going to be exponential of 2x. So this is going to be my y1 and also y2. So that's how you identify y1 and y2. Or if I were to give you another example, so let's say if I have the case of equal roots, so I get a plus bx exponential of x. So you have to expand it first. So you get a exponential of x plus bx exponential of x. So when you remove the a, you'll get exponential x. Remove b, you get x exponential of x. So those two are going to be your y1 and also y2. Or it could also be the other way around. It doesn't matter which one is y1 and which one is y2, as long as both of them are here. Okay, so basically this is going to be the idea. So how do you find y1 and also y2? Right, so after you have found your y1 and y2, what you're going to do is you're going to find the derivative of them. Okay, so you're going to find what is going to be y1 prime and what is going to be the y2 prime. So why do you need the y1 prime and y2 prime? Because you need those two elements in order to find the Wronskian. So this is called as Wronskian. It is denoted by capital W. That is the symbol. Okay, so if you remember, this is actually what is the symbol of this right here? So this is called as the determinant. So if you remember, if we have a matrix, so we can actually find the determinant of the matrix. For example, if I have a matrix of A, B, C, and D, so if I wanted to find the determinant of this matrix, so what I have to do is I'm going to use a formula, so which is going to be AD minus BC. So the first element multiplied by the last element, and the second element multiplied by the last element, by the third element. But the rule is going to be AD minus BC. So that is what happened over here. So this is my A, B, C, and D. When I apply AD minus BC, so it's going to be Y1, Y2 prime minus Y2, Y1 prime. And I would like to remind you the fact that Wronskian cannot be a value of 0. So if you calculate Wronskian, you get a value of 0, please go back to step number 1, because I would proceed marking your paper anymore, because in the formula later you can have Wronskian at the bottom, and we know that anything that is divided by 0, that is going to be undefined mathematically. Alright, so please make sure that you don't get 0 for your Wronskian. And actually Wronskian could be anything. It could be 1 term, it could be 2 term, it could be 3 term, but at your level, so we keep it at 1 term. So please, before you proceed with step number 4, simplify the Wronskian, make it into 1 term, then only proceed with step number 4. Okay, step number 4 is we're going to find the third and fourth component, because if you notice in terms of the solution, we already got y1 and y2. Now we only need to find u and also v. So this is going to be the formula of u and v. So u is given by negative integration of y2 fx over aw dx, and v is given by negative integration of y1 fx over aw dx. If you notice, the component is pretty much the same. There is only a slight difference between both of them. So the first difference is u is going to be negative integration, v is going to be positive. And for the case of u, at the top over here is y2. For the case of v, at the top right there is y1. That will be the only difference. Other than that, the element is going to be the same. And where do we get the fx? Okay, remember our equation is given by a y double prime and plus by prime, so plus cy equal f of x. So f of x is going to be whatever that you get on the right hand side of the equation. That is your f of x. And what is going to be a? So a is going to be the coefficient of y double prime. Whatever that you have, number that you have in front of the second order derivative, that is going to be your a value. Okay, and Wronskian, of course, Wronskian is going to be from step number 3. Okay, so those are going to be what you need for u and also v. And after you have found like all those elements, all you have to do is put them together. So the solution for y of x is going to equal u y1 plus vy2. That's it. For the case of VOP, you don't have to worry about linear independency or linear dependent. Nope. You only have to use these formulas, okay? And you don't need to memorize any of these formulas. So the formulas are going to be given in the appendix section, okay? Whether it's going to be a test or it's going to be your final exam. So the formulas are given. Alright, so now I'm going to demonstrate by using this particular example right here. I'm going to use the VOP method to solve for this equation.